Singapore 6, you are cleared for takeoff. Runway 05 left.
During the takeoff, your heartbeat goes up a bit.
Okay, thrust left, toga.
Taking off is a complex task.
Ignition set. Spoilers armed.
Pilots need to carefully execute multiple steps to get their plane into the air.
100 knots.
But sometimes mistakes are made,
They didn't follow procedures precisely.
with tragic results. In Taiwan, a 747 fails to take off in a typhoon.
I thought I was gonna die.
A departure from Detroit goes horribly wrong.
Why didn't pilots perform the task?
In a matter of seconds, an MD-82 is out of control in Madrid.
Fly the plane. Fly it.
On 3 different flights, small missteps ended in tragedy. Taipei, Taiwan. Singapore Airlines Flight 6 taxis to the runway through heavy wind and rain. Typhoon Jiangsen is closing in on Chiang Kai-shek Airport. Flight 6 needs to get airborne before the storm hits.
Even a 747 can't take off in an actual typhoon. So the closer the storm gets, the more likely is that these guys are going to get stuck in Taipei.
There are 179 people on board the overnight flight to Los Angeles, California.
Singapore 6, for your information, surface wind 020 at 24, gust 43.
Thank you, sir. Singapore 6. Let me know when it's 30.
If the crosswinds reach 30 knots, Captain Fong Chi Kong will have to abort the takeoff.
As we were taxiing down the runway, it was very windy and the plane was moving left to right.
Singapore 6, you are cleared for takeoff. Runway 05 left.
Okay, thrust left, toga. Okay, my control.
The 747 accelerates to reach the takeoff speed of 180 miles an hour.
V1. V1.
As the plane was gaining speed to take off, at a certain time, the plane kind of lost it.
What's happening?
I felt the airplane spinning around. I thought I was gonna die.
After skidding down the runway, the 747 finally comes to a stop.
Then I opened my eyes and I saw a fireball coming at me.
Direct emergency vehicles to runway 05 left. Singapore 6. Do you read? Singapore 6.
Let's go, go!
The plane's tanks are fully loaded with tons of fuel. Fuel for a fire that rescuers battle in this violent storm.
It takes about 15 minutes to control the fire and 45 minutes to extinguish all of them. So it's a difficult task for the firefighters.
"83 people have died. There are 96 survivors, including the pilots. One of Asia's busiest airports is immediately shut down. It's now up to the Aviation Safety Council of Taiwan to determine the cause of the disaster.
When I went to the crash site, I can see all the wreckage spread the wrong way.
Flight 6 was cleared for takeoff on runway 5 left. But much of the wreckage is spread over runway 5 right. Investigators wonder whether the typhoon blew the plane off its runway.
When you're an investigator looking at a crash scene, you have to keep an open mind. You have to assume it could be any conceivable factor, from the machinery, the human factors, to the weather, to who knows what.
As investigators, we believe that we should interview pilot or operator as soon as possible, because we believe that human memory will fade over time.
Captain Fong Chi Kong is interviewed within hours of the crash.
What happened? We collided with something on the runway. There's something there! There was something on that runway.
Could you tell what it was?
No. We could not see all the way down the runway.
The focus shifts from the weather to the possibility that there was an obstacle on the runway. Investigators examine the wreckage for clues.
It's difficult for us to collect all of the information, all of the wreckage, because it's blown to everywhere.
Accidents during takeoff can involve more than one aircraft. In 1991, a SkyWest Metroliner preparing for takeoff from Los Angeles was crushed by a US Air 737, which was coming in to land on the same runway. 34 people were killed. Is that what happened to Singapore Airlines Flight 6?
Any signs of another plane? And no other flights unaccounted for.
At Chiang Kai-shek Airport, this theory is ruled out. All of the debris appears to be from just one plane, Flight 6.
He didn't hit a plane.
Investigators work through thousands of pieces of mangled wreckage.
Part of the flap assembly. Right wing.
They make an unexpected discovery. Some wreckage doesn't belong to the shattered 747. It looks more like construction equipment. Chiang Kai-shek Airport has 3 runways. Runway 5 left is the one Flight 6 was instructed to use. Parallel to that is runway 5 right, a runway closed for construction. Investigators consider the possibility that Flight 6 hit material from the construction site.
It wouldn't be hard to imagine some large object being blown into an engine or knocking out the windshield. There's lots of things that could have happened.
There's something there!
When investigators look at runway 5 right, adjacent to Flight 6's designated takeoff runway, they see something that doesn't make any sense. Fresh tire tracks on a runway that is supposed to be closed.
We can actually see the tire mark of this aircraft starting from the takeoff point all the way to the first impact point.
The tire marks on runway 5 right lead investigators to a startling conclusion.
This is our point of impact.
It seems Flight 6 was taking off from the wrong runway. But how could 2 experienced pilots make that mistake? The only way to determine what went wrong is with the data from the black boxes.
When we get the information out of the recorder, we read it, then we can know the exact position of the aircraft.
Investigators compare positioning information from the flight data recorder to a satellite image of the airport.
Well, he's lining up with the wrong runway.
Somehow, the plane ended up on runway 5 right instead of 5 left.
It was supposed to be here. How did they end up here instead?
1,243 meters down the runway, he collides with the construction equipment.
It seems like the kind of thing that shouldn't happen, ever, under any circumstances.
Investigators need to know why Singapore Airlines Flight 6 tried to take off from the wrong runway at Taiwan Airport. Investigator Thomas Wang interviews Captain Fong again.
Did you receive this notice?
He has questions about a notice that runway 5 right was closed.
Of course I did. Everyone did. We discussed it during our briefing. Tell them we'll take 5 left.
So why didn't air traffic controllers realize that the 747 had turned onto the wrong runway?
I couldn't see them in that weather.
When interviewed, the controllers said that night's storm limited visibility to around 2,000 feet.
And they runway 5 left. That's the last I heard from them.
1,600 meters between the runway and the tower. There's no way he saw them.
The crew assumed the tower was monitoring their progress, but the controller had lost sight of the plane. Investigators now try to determine how the pilots lost their way.
We couldn't see very far, but we could see far enough. Cyrano studied the map while I followed the taxi lights. It led us directly to the runway.
Okay, green lights are here.
It appears that the crew had no trouble seeing their taxi route.
Was this the map you were using?
Yes.
You didn't have any trouble reading it?
I wasn't reading it. My first officer and the relief pilot were following the map. I only glanced at it when the route changed.
They changed the route?
Yes.
Wang learns that the ground controller issued a last-minute change to their taxi route.
Singapore 6 requests taxi.
Singapore 6, taxi to runway 06 via taxiway. Correction, runway 05 left via taxiway Sierra Sierra, West Cross, and November Papa.
Pilots have to deal with last-minute changes all the time. The situation becomes complicated, it becomes hairy. Now you've got a typhoon bearing down on you, you've got gusts, so you're under pressure.
Did additional workload in the cockpit cause the pilots to make a fatal mistake? Investigators turn to the cockpit voice recorder.
It's coming in fast. The longer we delay, the worse it's going to get.
The CVR reveals that the crew wanted to get off the ground before the weather closed in.
Singapore 6, runway 05 left. Wind 020 at 28, gust 50. Cleared for takeoff.
Normally, a 747 taxis about 25 knots. On this night, they're going 9 knots. They're doing exactly what they should have done, taking it nice and slow.
The pilots pass signs that clearly identify the runways.
I'm going to go very slow here, otherwise we'll skid.
Indeed, he's crawling.
.020 from the left.
020.
The winds consume the crew's attention.
28.5. It's getting close to 30, sir.
Okay.
The captain was taxiing the aircraft in very slow speed, and the first officer is doing the before takeoff checklist, and the relief pilot is working on the crosswind component. So all pilots, they are occupied by something. They do not have enough attention to actually check which runway they are taxiing onto. They believe they are making a right turn onto the correct runway. Unfortunately, that's not the correct runway. That's 05 right.
Captain Fong's extreme caution might have worked against him.
Okay, 9 knots.
Because the turn took so long, Captain Fong may have believed that he'd gone further than he actually did. So much time had passed that he may have thought he had actually reached runway 5 left.
The big irony of this crash is that they were taking off in very dangerous circumstances, near the limit of what their plane was capable of handling. But it wasn't the weather that did them in, but rather the pressure of dealing with the storm distracted them from what turned out to be the real question: were they in the right place?
V1.
V1. There's something there.
One of the lessons of this accident is that you can have an exemplary crew performing their duties with utmost care, and they still make a mistake with fatal consequences.
Taiwan's Aviation Safety Council recommends immediate changes to pilots' procedures and training.
Currently turning left onto taxiway November 1.
New checklists are designed that include a visual step, obliging pilots to confirm that they're on the correct runway before takeoff.
Singapore 006 reminded us again that if there's ambiguity in the cockpit and you're on the ground, you need to resolve and stop and get that resolved, particularly in very, very inclement weather. When visibility is reduced, you need to be sure where the airplane is.
The crash of Singapore 6 isn't the first time a series of missteps during takeoff leads to disaster. Detroit Metropolitan Airport. More than 1,100 airplanes use one of its 4 runways every day. Northwest Airlines Flight 255, an MD-80, is bound for Phoenix, Arizona. There are 149 passengers on board. Captain John Mouse is in command. A Las Vegas native, 57-year-old Mouse is a veteran pilot. His first officer is 35-year-old David Dodds of Galena, Illinois.
Look at this.
Today, storms darken the flight path between Detroit and Phoenix. Several are moving quickly towards the airport.
There's a line here, and another one here about 25 miles wide. Well, if we get out of here pretty quick, we won't have a delay.
Northwest 255, cleared to go.
Already running a half-hour late, Flight 255 is cleared to taxi to the runway.
Let's do the checklist. Brakes, set, windshield heat. He's on. Boost the pumps. That's 6. Get pumps and pressure. On and checked. Damn. It's starting to rain.
To beat the storms, they must leave immediately.
They're all on. Before start checklist is
Flight 255 moves away from the gate and towards the runway. But the bad weather...
Northwest 255, now exit at Charlie runway 3 center.
Forces a last-minute runway change.
Okay, out to Charlie for 3 center, Northwest 255. Charlie for 3 center right. Okay. Ladies and gentlemen, we're currently number 1 for departure. We should be rolling in a couple minutes. Blacker than hell out there. Where's Charlie at?
By the time they get to the new runway, they are 45 minutes behind schedule.
Northwest 255, runway 3 center, clear for takeoff.
Flight 255 hurtles down runway 3C.
Clamp, 100 knots. V1, rotate.
The pilots angle the plane's nose up for liftoff. But less than 50 feet off the ground, Flight 255 is in trouble. Moments after takeoff,
Tower, lifeguard copter 102.
Northwest Airlines Flight 255 is out of control. The trail of debris is more than a mile long. Remarkably, a 4-year-old girl has survived the crash. Rescuers spend hours searching the wreckage for other survivors. But the young girl is the only one. 154 people on board, including Captain Mouse and First Officer Dodds, have been killed in the crash. On the ground, 2 people died in their cars when they were hit by the plane. Investigator Jack Drake and his team from the National Transportation Safety Board begin the search for clues.
You know when you're at a crash site because you get this combination of burned plastic and kerosene, and sometimes combined with a fire retardant foam that has its own distinctive odor.
The cockpit voice recorder is intact, but the flight data recorder has been damaged in the crash. Both recorders are sent to the NTSB lab in Washington, D.C. John Clark is the team's flight performance engineer. He searches for ground scars and other impact marks, and interviews witnesses to piece together where the plane fell and how.
When I first started seeing the wreckage, your mind immediately starts turning to sorting out where it hit, how it hit, not where the wreckage ended up, but those first few inches where the airplane was coming down.
According to witnesses, Flight 255 lifted off in a nose-high position, but then couldn't climb.
V1, rotate.
That clue could indicate that the plane didn't have enough speed to get off the ground, or that high winds prevented it from lifting off. Until technicians can decode the damaged FDR, the team must rely on physical evidence from the crash site. Investigators study the cockpit's center console. One thing stands out.
Is this the way it was found?
The lever that extends and retracts the wing's flaps and slats. Flaps and slats are extensions that slide out of the back and front of the wing. They make the wings larger, increasing the amount of lift they can provide. They must always be extended for takeoff. But the way the flap handle is damaged suggests the plane's flaps were not extended when it crashed.
The pin had left a mark. This happens because the aircraft comes to a very sudden stop and the handle jangles around, metal-to-metal contact that's exaggerated by the impact. That indicator was that the flaps were 0 or fully retracted and the slats were retracted as well.
Even without data from the FDR, investigators can determine the flap position at takeoff.
V1, rotate.
Flaps and slats are moved by cables running through the wings.
Each component of the slat system has its own drive system, and one of those was interrupted by the light pole that passed through the wing.
When they examine the left wing, investigators see that the cable controlling the slats sliced in two when the wing hit the pole. By examining the cut cable, investigators can tell whether the slats and flaps were extended or retracted.
It severed two cables. If you lined up those two severed ends, it corresponded with the slats being in the full retracted position.
When data is finally extracted from the FDR, the report confirms what the cut cable suggested. The flaps were not extended on takeoff. It's a major breakthrough. Jack Drake now knows what brought down Flight 255. But the flight data recorder can't answer a more troubling question.
So, why weren't the flaps deployed?
For some reason, a seasoned crew allowed a critical misstep to occur while getting their plane off the ground. Why did the crew of Northwest Airlines Flight 255 fail to extend the flaps on takeoff? Investigators listened to the cockpit voice recorder again for answers. It indicates that a last-minute runway change led to confusion in the cockpit.
Northwest 255, now exit at Charlie runway 3 center.
Did he say 3 center? 3 center, yeah, that's why I was thinking we had to go that way. I was thinking 2-1.
Well, they made a wrong turn, which might have been confusing because they had to go a different route.
Around Northwest 255, I guess we went by Charlie. We're going to 3 center right.
Northwest 255, affirmative, make a left turn.
They finally arrived at the runway 45 minutes late.
We're okay for the center runway, aren't we?
Before they lost their way, the crew of Flight 255 carried out a number of checklists, but missed the taxi checklist.
They apparently didn't consider the checklist, and key in the checklist is the configuration of the aircraft for departure.
The first item on the taxi checklist is flaps. And because they didn't run the checklist, the crew neglected to set their flaps to takeoff position.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
They hadn't done this checklist at the time they normally would, and as the activities piled up that were potential distractions, they were further and further away from the point at which they would normally perform that function.
After the checklists, there is a last line of defense designed to prevent pilots from taking off without flaps set. An alarm should have sounded when the pilots started down the runway with their flaps retracted.
Maybe it went off, but we just can't hear it.
But no alarm is heard on the CVR. When investigators consult other MD-80 pilots, they're told the takeoff configuration warning was a nuisance at times.
Flaps, slats, flaps.
If you're doing a single engine taxi, you have to push the throttle up further to get a power to taxi, and you set off the takeoff warning system. And if it's going off routinely all the time, it gets on their nerves. So apparently pilots were routinely silencing those takeoff warnings.
Investigators suspect that the crew of Flight 255 pulled a breaker to avoid the irritating takeoff warning. It's determined that the downing of Flight 255 was caused by pilot error. The FAA orders a modification to the alarm system of all commercial jetliners to prevent nuisance alarms.
I think a big lesson learned that a strict adherence to checklists is very important. Checklist, in my mind, is kind of the fabric that holds a flight together. It has to be religiously followed.
21 years after Flight 255's deadly crash, another tragedy shows flight crews were still missing critical steps during takeoff. Madrid Barajas Airport, Spain.
Ladies and gentlemen, thank you for your patience. We hope to be on the move again very soon.
At the last minute, Spanair Flight 5022 is delayed. There's a problem with a temperature probe. While it's checked out, the air conditioning is turned off. Passengers are sweltering in the heat.
So we're done? Yeah, pop the breakers, so you're good to go. Okay, thanks.
After a delay of more than an hour, Spanair Flight 5022 finally gets going. There are 166 passengers on board the flight bound for the Canary Islands. Today, Captain Antonio Luna is in command. A former Spanish Air Force pilot, he's been with Spanair for 9 years.
How's our time? About an hour and a quarter behind schedule.
First Officer Francisco Mulet joined the company just 1.5 years ago.
Spanair 5022, Joe Nexon line on runway 36 left.
Okay, here we go.
Preparing for takeoff is an extremely busy time for the flight crew. They've got multiple checklists that they have to run.
Ignition, set. Spoilers, armed.
Make certain the aircraft is properly configured, the thrust is set right, the brakes, etc.
Air conditioning?
So there are a plethora of factors that are all running through their minds simultaneously.
Spanair 5022, you are cleared for takeoff, runway 36 left.
Cleared for takeoff. Spanair 5022.
Just after 2 p.m., the MD-82 aircraft starts speeding down the runway.
100.
The captain monitors their speed. They can't lift off until they reach 157 knots.
V1, rotates.
Suddenly, an alarm sounds. Something is wrong.
Engine failure?
At Madrid Barajas Airport, an MD-82 is approaching disaster.
How the hell do you turn off that warning?
The plane is less than 40 feet off the ground.
Fly the plane. Fly it.
Just seconds after takeoff, Flight 5022 slams into a riverbank alongside the runway. Airport fire crews race to the scene. The plane, with 172 people on board, is now shattered wreckage spread over half a mile. Only 18 people survived the crash of Spanair Flight 5022. 147 passengers are dead. So are both pilots.
It was a tremendous tragedy. All the country was affected by that.
Spain recruits an international team of experts to investigate the country's worst aviation disaster in 25 years.
Okay, people. It looks like we have our work cut out for us.
Marks on the ground paint a vivid picture
Here's our first impact.
that reveals just how soon Flight 5022 hit the ground. The first impact marks are just 200 feet from the runway. The plane then passed over a road and slid another 1,800 feet before crashing on the far side of the river.
This airplane left a trail coming from the runway to the edge of the airport boundary. So it was quite clear for the investigation that the airplane had big problems just on liftoff.
Investigators wonder if engine failure compromised the takeoff.
If we find mud, soil, or grass throughout the engine, we can determine that the engine was fully operational at the time of the accident.
Both engines are filled with debris ingested during the crash. The finding means the engines were running when the plane made impact.
The engines were fine, but something stopped that plane from climbing.
Controllers working the day of the crash present a potential lead.
They had some kind of maintenance issue right before takeoff.
Madrid Spanair 5022, we have a slight problem.
We have to exit the runway.
Investigators hear about the trouble with the temperature sensor.
Oh yeah, I took a look, but it wasn't serious.
The sensor, called a RAM air temperature probe, measures the outside air temperature and feeds the information to the plane's computer during flight. The sensor was sending out faulty readings.
Check the ice protection meter selector.
No, that didn't work either.
Without it, the automation that adjusts engine power won't function properly.
Look at that. It says 104 degrees now.
Maintenance workers were unable to repair the faulty sensor.
Right, got it.
So they temporarily cut the power to the sensor, thereby disabling it.
So, we're done?
Yeah, pop the breakers, so you're good to go.
Okay, thanks.
Investigators wonder if the disabled temperature probe is somehow linked to the crash.
I don't see how this could cause a problem.
But they quickly confirm that the probe is not an essential piece of equipment. The crew can keep track of the outside temperature themselves and then adjust engine power manually. Something else prevented the plane from climbing out.
What kind of wreckage have we recovered from the wings? Get me everything you have.
Investigators turn to the MD-82's control surfaces. They study the lever mechanism that pilots use to adjust the flaps.
The flap lever was an essential part of the investigation.
Well, well, what have we here?
There's a deep scratch at the 0 mark, the retracted position. It's a startling finding, one that suggests the flaps on Flight 5022 were not extended on takeoff. It's disturbingly similar to the crash of Northwest Airlines Flight 255 21 years before. Did the pilots in Madrid, like those in Detroit, fail to set the flaps properly before takeoff?
V1.
What happened to prevent them from being in the right position?
Rotates.
The answer to that question could explain why 154 people died. Investigators need to know if the pilots of Spanair Flight 5022 took off without the flaps extended. They don't have a voice recording for the first takeoff attempt. It was erased when the MD-82 left the runway and powered down for maintenance. But they do have all the information from the flight data recorder.
Flaps were set at 11 degrees on the first taxi, exactly where they should be.
The flight data recorder reveals that the flaps were set correctly when the plane taxied onto the runway the first time. Then the pilots noticed that there's a malfunctioning temperature probe.
Madrid Spanair 5022, we have a slight problem. We have to exit the runway.
When the crew returned to the terminal for repairs, they retracted the flaps.
Flaps and slats are retracted after coming off the runway as part of standard operating procedure.
We're done?
Yeah, pop the breakers, so you're good to go.
Thanks.
Taxiing back to the runway, the pilots should have extended the flaps for takeoff. The MD-82's pre-flight checklists direct the crew to check the flaps and slats 3 times.
Ignition, off. Air conditioning, set.
On the after-start checklist, setting the flaps is the final step.
Hydraulic pumps and valve.
Set and checked.
Lights.
On. Get permission from air traffic control to taxi, will you?
Hold it. What is he doing? This is the worst possible time to interrupt him.
The CVR reveals that just as the first officer is about to check the flaps and slats for the first time, the captain instructs him to make a radio call.
Ground, Spanair 5022, requesting taxi instructions.
Spanair 5022.
He didn't return to the checklist to finish that critical step.
Humans are fallible, and we know that when we're multitasking, it's very easy to forget or miss a critical item.
And they never set the flaps.
The captain and first officer then fail to carry out this critical step on the final 2 checklists.
Transponder, set. Captain.
Hang on, stop. Where's the takeoff briefing?
Investigators now know what caused the crash of Spanair 5022.
V1, rotates.
The pilots never extended their flaps before takeoff, making it impossible for the plane to climb. And just as with Northwest Flight 255, investigators must answer a key question.
Where's the warning?
If the flaps were not set in the takeoff position, there should be a very conspicuous sound saying that the aircraft is not ready for takeoff.
Once again, why didn't the alarm sound to warn the pilots that their flaps weren't set?
These failures have to be connected somehow.
Investigators look for a link between the failure of Flight 5022's takeoff warning and the failed temperature sensor.
Look at that, it says 104 degrees now.
Investigators trace the complex pathways for the temperature sensor and the takeoff warning. They make a critical discovery. The sensor and the takeoff warning both pass through a single electronic relay, the R25 relay.
It was very shocking to find out that 2 different systems, like the takeoff warning system and the RAM air temperature probe heating, were controlled by the same device.
Investigators suspect the R25 relay failed, disabling both the temperature sensor and the takeoff warning. Technicians are not able to recreate that failure in the lab, but for Juan Carlos Lozano, the theory makes sense.
That's it. That's the link.
In my opinion, the Relay 25 was the cause of the failure of the takeoff warning system.
Right, got it.
With no takeoff alarm, the pilots lost a critical line of defense. Just like the Northwest Airlines pilots in Detroit, the Madrid crew's failure to follow their checklists led to tragedy.
Single biggest failure in this accident is the failure of the takeoff warning system. This system was designed considering that the humans can make mistakes. And this is a clear example that the last line of defense failed.
After the crash of Spanair 5022, Boeing revised its checklists again to make extending flaps and slats even more prominent. 3 disastrous takeoffs lead to changes that have made a critical period of flight much safer.
Technology is helping us with all 3 of these accidents. The takeoff warning systems are better on the more modern airplanes, so that if a crew attempts to take off, they get very definite warnings. Moving map displays that are now available for when you're taxiing on low visibility. It physically shows the airplane on an electronic map. That reduces the ambiguity about your position. So technology is helping us there, but it still comes back to good decisions, conservative decisions, and the adherence to standard operating practice.